All right, objective 4. You find the vertex of a quadratic function from standard form. All right, if you remember, standard form can be written as y equals ax squared plus bx plus c, standard form quadratic function. I'm going to do an example of how to find the vertex in standard form, and then I'll have you pause the video and try your own example to check your understanding and check your work with mine. So to begin, if I was given this example, y equals negative 2x squared minus 4x minus 3, the biggest clue that tells me this is standard form is that there are three terms. There's an a term, a b term, and a c term, and that it's written in descending order. And what I mean by that is the highest power is 2x squared, and then the next power is 1, x to the first power, which is the b term right here. And then the final term is the constant c that does not have a variable. So standard form is written highest power to lowest power in descending order like that, right? And it has three terms, and it mimics the standard form of y equals ax squared plus bx plus c. That's how I determined that it is standard form that I'm working with, and now I can find objective 4, find the vertex of a quadratic function from standard form. Now, again, standard form can be written as y equals ax squared plus bx plus c, where a, b, and c are all real and rational numbers. Now, I'm going to do an example, then I'll have you pause the video, try your own example to check your understanding before moving on to the practice work. And with this example, I'm going to use the following steps written in red to successfully find the vertex if given standard form. So, this example, y equals negative 2x squared minus 4x minus 3. The first thing I would consider is it does mimic the standard form I just talked about. It looks to have an a term, a b term, and a c term. And the highest power is written first, the quadratic term. The power of 2 is first. Then the power of 1 is second. And then the constant term is third, the term with no variable. So that's the other qualifier of standard form. It has to be written in descending order in reference to the power. So the highest power goes first, and the term with no power goes last, and it goes highest to lowest. So we've determined its standard form. In order to find a vertex in standard form, the first step I'm going to take says to identify the a, the b, and the c terms. So I'm going to write my first step, and this is an important skill to have in this module and the next module when you start to solve quadratic functions as well. And since it is in standard form, it's pretty straightforward. My a term is the first coefficient listed. In this case, it's negative 2. My b term is the second coefficient listed. In this case, b is negative 4. And then my c term is the constant written at the end. So c equals negative 3. C is always the term without the variable at the end. All right, so I've done step 1. I've identified the a, the b, and the c terms. Moving on, step 2 involves a formula. So you use the following formula to find the x value of the vertex. If you notice in this formula, I'm going to read it as x equals opposite b over 2a. There are two variables I care about in this, the b and the a. And conveniently, we just found the b term of this function and the a term of this function. So step 2, I'm just going to take those values that I have for b and a and input them into the formula where I see the corresponding values. I'm going to write x equals opposite of whatever b is. You can say negative b over 2a, but that confuses me with the sign, whether it's positive or negative, so I'm just going to say opposite of whatever b is. So in this case, b is a negative 4, so opposite of negative 4 becomes positive 4. So instead of the b, I'm going to write positive 4 over 2. And indicate multiplication because it's 2 times a. I want to use parentheses. So 2 parentheses, my a term is negative 2. That one is not opposite. B is always opposite in this one. So I've correctly inputted the values into my formula. I have a b and an a term. Next thing I'm going to do is clean up the denominator first. So I'm going to do 2 times negative 2, which is negative 4. So my new fraction becomes 4 over negative 4, 4 divided by negative 4. And then finally, that math will give me an x value of 4 divided by negative 4 is negative 1. So I have found my x value of negative 1. Very important. So now my task is step 3. Step 3 says to plug the new x value that we just found into the original equation, which is up here, and I will use a different color. Up here, that's the original function. I'm going to plug the x value of negative 1 into these x variables to spit out a value for my y. If you notice, it's y equals. So if I input a value into those x's and do the math, it will give me that y value of the vertex at x equals negative 1. So step 3, plug x value into the equation to find y value. So I'm going to write it, and I would encourage you to write it exactly like I am, using parentheses to represent the new value that's being inputted into the x's. I'm going to put y equals negative 2 parenthesis squared. I'll come back and put the value in later. Minus 4 parenthesis minus 3. So if you notice, it's the same thing as this function up here, but instead of the x's, I have put parentheses because those variables, the x variables, are going to change to my x value that I found in step 2. So I'm going to put negative 1, the x value, into both parentheses says. And then I'm just going to do that math. You can use your calculator if you want and put that exactly like you see it in your calculator, and it'll give you the y value. We're just going to do some mental math. So in this first chunk, negative 2 parentheses times negative 1 squared, we do the power first, so negative 1 squared is positive 1. Negative 2 times positive 1 is negative 2. So this becomes negative 2. Then I have a negative 4 times a negative 1, which turns to positive 4. And then I have minus 3. And then finally, that math gives me negative 2 plus 4 is 2. Minus 3 is negative 1. So my y value of the vertex is negative 1. Which means the vertex of that original function, negative 2x squared minus 4x minus 3, where this parabola begins, is at negative 1, comma, negative 1. And again, we're not going to tell the y-intercept or the x-intercept yet. That's going to come later when we draw these things. But I can also distinguish if it'll open up or down. In this case, it's determined of the a term. The a term is negative 2. So it's going to open down because it's negative. And that means the parabola has a maximum. And then finally, the axis of symmetry is always the x value of the vertex, so x equals negative 1. And I'm done. I have found, if given standard form, I have found the vertex of a quadratic function in standard form. Please pause the video, try this, finding the vertex of this function on your own, and then check your work with mine when you're done. Make sure to pause the video and try this example on your own. Please check your work with mine. I've listed out step by step how I've done each step and the math that goes with it. And I would love for you to get in the habit of listing out step by step how you do problems as well. It really helps me to see your thinking through each problem. So given standard form, 3x squared plus 12x plus 5. Step 1, I identified the a, b, and c terms. Step 2, I inputted into the formula x equals opposite b over 2 times a. In this case, b was 12, so the formula has to be a negative 12. And then I clean up the denominator, so now it becomes negative 12 divided by 6. So my x value of the vertex is negative 2. And then I input that x value back into the original function. And I showed that in step 3. And that math gave me y. The y value of the vertex is negative 7. So my vertex is negative 2 comma negative 7. The original function, the a term, was 3, so that's a positive 3, so it'll open up, which means it has a minimum, and the axis of symmetry is the x value of the vertex, which is negative 2. If your work does not look like mine in this problem, please raise your hand so we can talk through it. And thank you for watching.